In this lesson we will discuss parallel RL and RC circuits. The circuit shown illustrates a parallel circuit with an inductor and a resistor connected in parallel across a voltage source V sub S. Kirchhoff's current law applies, however a Phasor diagram must be used. Applying Ohm's law, the equation for current through the inductor is I sub L equals V divided by X sub L. Drawing the Phasor diagrams, we get the following figure. It is evident that I sub L lags V sub S by 90 degrees. The Phasor diagram can be redrawn as shown. The phase angle can be found by the following equation, where theta is equal to the inverse tangent of I sub L divided by I sub R. Using the circuit shown, find I sub S. X sub L is equal to 2 times pi times F times L, or 5,654.9 ohms. I sub R is equal to V divided by R, or 14.5 milliamps. And I sub L is equal to V divided by X sub L, or 5.66 milliamps. I sub S is equal to the square root of I sub R squared plus I sub L squared, or 15.57 milliamps. And theta is equal to the inverse tangent of I sub L divided by I sub R, or 80.7 degrees. The total current lags the supply voltage by 80.7 degrees. In this circuit, a capacitor and a resistor are connected in parallel across a voltage source V sub S. The branch currents can be calculated as follows. I sub R is equal to the source voltage divided by the resistance. I sub C is equal to the source voltage divided by the capacitive reactance. I sub S is equal to the square root of I sub R squared plus I sub C squared. And theta is equal to the inverse tangent of I sub C divided by I sub R. The capacitive reactance is equal to 2 times pi times the frequency times the capacitance. The phasors can be drawn as shown in this figure. Let's now look at an example. A parallel RC circuit consists of a 5 k ohm capacitive reactance and a 3 k ohm resistor connected across a 125 volt source. What is the total current and the phase angle? Applying Ohm's law to each branch, we get the current through the resistor I sub R is equal to the voltage divided by the resistance, or 41.7 milliamps. The current through the capacitor is equal to the voltage divided by the capacitive reactance, or 25 milliamps. And the source current I sub S is equal to the square root of I sub R squared plus I sub C squared, or 48.6 milliamps. Theta is then equal to minus the inverse tangent of I sub C divided by I sub R, or minus 30.9 degrees. The total current I sub S leads the voltage by 30.9 degrees. The capacitive current I sub C leads the voltage by 90 degrees. I sub R has the same phase angle as the voltage, 0 degrees.